Hello Trig class. In this video we are continuing to work on the practice test from section 9.1, which is on the law of sines. We've used the law of sines as just one equation to solve the first 7 problems, and we'll probably keep using it here in number 8. So let's describe the situation first. It says Dolores flies a hydroplane and is descending towards an ocean. So a hydroplane is probably what I would call a seaplane, a plane that can land on water. And it says that it makes descending at a 9-degree angle. So let's say that this line is parallel to the ground, and then a 9-degree descension angle would look like this. 9 degrees from the horizontal. Okay. So that would be looking forward towards the ocean, which I'll call O for ocean. But if she looks behind her, there's a 55-degree angle, so we'll do it as like a descension angle again. So this will be like 55 degrees. So the whole line is 180 degrees. If you take 180 minus 55 minus 9, that's 180 minus 64. That means this one's 116. Okay, and then on this angle lies a forest. So let's say the forest is here, and it's 55. What is it? There's a distance between the forest and the ocean, and it's 200 yards. Okay, so I've got this angle and that length, but I'm going to need another angle or length, one or the other, but I'm not going to get another length out of that. But if this is 9 degrees and these are parallel, then this is also 9 degrees. The reason that is because if you don't have to do this, but that's a alternating, what they call an alternating interior angle. But if you were going to go and cut this one and say make a 90-degree angle here, that would leave 81 degrees left over from that 9. And if this was 81 and this was 90, there'd only be 9 degrees left, so that would be 9 degrees here. So if it's 9 degrees here, it's 9 degrees here if these are parallel. And we're going to assume that there's a straight line from the ocean to the forest, which would make it the shortest distance, and you'd measure it by the shortest distance. Okay, so this is 9 and that's 116, that's 125 total. Then this is 55, which again it would have to be because it's alternating interior angle, just like this is. If this is 55, then this one over here has to be 55. Okay, how much further does she have to fly until she lands? So we are looking for, here's her plane. We're looking for that distance. Now the angle across from it is 55, so we'll use the sine of this angle, sine of 55 degrees, divided by this length that I don't know, which I'll call C, the one we're trying to find, is, then we know this angle, we know this side, so we'll say the sine of 116 degrees divided by 200. So C, the sine of 116 degrees, this guy times this guy is equal to this guy times this guy, so that's 200 times the sine of 55 degrees. So C is 200, the sine of 55 degrees over the sine of 116 degrees. Okay, so let's work that out. Calculator. Calculator, that's 182.3 if you round to the nearest tenth. Yards, because the other one was in yards. Okay, again, that's law of sines. The sine of an angle divided by its opposite side is a constant in triangle, in any triangle. Okay, the next one is a area problem, and so is the one after that. So that doesn't use the law of sines. The next one says use the law of sines. So we're going to do the one that we've been using all along, and then we'll go on to the others. Okay, so let's see. We want to find B. That's 53 degrees. So the sine of 53 degrees divided by the opposite side is the sine of 20 degrees divided by its opposite side from the angle, which is 8. So 8 times the sine of 53 degrees is equal to B times the sine of 20 degrees. So B is 8 sine 53 degrees divided by the sine of 20 degrees. And if you work that out in a calculator, that's 18.68 in length. It doesn't say the units, so I'm just going to say 18.68 in length. Okay, now there's two other ones, but they are area problems. So there's only one other formula in this section besides the law of sines. Now this is the law of sines one, which we've been using over and over again. Okay, that's like 90% of the problems. The other is for measuring the area of a triangle if you know two side lengths and an included angle. And the area of the triangle is 1/2 the product of the side lengths times the sine of the angle in between them. So they have to give you that information. This one says that your area is a triangle. So here's a triangle. And there's sidewalks here. It's 69 on one side and 80 on the other. And the two sidewalks intersect at a 73-degree angle. So that's this angle. Okay, so here's two sides and an angle that's between them. So the area would be 1/2 times the product of the side lengths times the sine of the angle in between them, and you just go get that in a calculator. See what it is. That is 2639.40. 2639.40 square feet. Okay, we got one left. Okay. So, an A-frame house. Okay, an A-frame house is a triangle. A-frames look like this on one end. You don't have to draw the other part, but if you keep drawing them, they look like that. And this would be like the front. Roof intersects at a 54 degree angle. Okay, so this would be like the intersecting part. So that's your angle. And it's 18 feet long from the peak to the ground. The roof is 18 feet long. Okay, so I'm going to take this measurement to be 18. Now it's straight down. And they would be the same because an A-frame would be symmetric. So if that's the right setup, it's 1/2 times the product of the side lengths times the sine of the angle in between. So let's see what number we get. That's 131.06. And that would be square feet. And that's the only problem we haven't worked yet. So I will see you later.